Welcome back. In this video, we're going to go over section 6.6, which is about dividing polynomials. We already saw how to divide monomials in the last section. We saw that boiled down to dividing the coefficients and subtracting the exponents. So here, we'll begin where we're dividing polynomials by single terms and then make it more complicated in a few minutes. So to begin with, we have 8y squared plus 24 divided by 4. So the overall approach is to take and separate the two terms, or the one term, into two separate terms, each of which here has a denominator of 4. So now, sorry about that, Zoom crashed once again. So we have 8y squared divided by 4 is 2y squared, and then 24 divided by 4 will give us 6. So we'll end up with 2y squared plus 6. Okay, in the next term, or next problem, we have 27b cubed minus 33b squared. We're going to divide that by 3b. So our first step will be to separate that into two separate terms. We have 27b cubed divided by 3b minus 33b squared divided by 3b. So now 27 divided by 3 will be 9, and b cubed divided by b is b squared, minus 33 divided by 3 is 11, and then b squared divided by b give us a single b. Okay. The next one is going to play out very similarly. What's different in this one is the denominator has a minus sign in it, and that's really the only difference. How we're going to process it is going to be the same as we were doing in the preceding examples. 25y squared divided by negative 5 will give us negative 5y squared. And then in the next part, we're subtracting a negative, so that will become an addition. And 15 divided by 5 will be 3. And we will still have our y is supposed to have been a single y, or y squared in the original problem. We'll take that off. So sorry about that. Okay, now it is okay. Negative 5y squared plus 3y. Okay, so let's try this next one next. We have 60a to the 7th power plus 24a to the 5th power divided by 4a cubed. So why don't you pause the video and try this one and then restart the video and see how you did. So with this one also, we're going to separate our problem into two separate terms. So we have 60a to the 7th divided by 4a cubed, then 24a to the 5th power divided by 4a cubed. And we'll divide each of these separately. For the one on the left, 60 divided by 4 is 15. And then a to the 7th power divided by a cubed will give us a to the 4th power. For the second term, we have 24 divided by 4, which is 6. And then a to the 5th power divided by a cubed, which will be a squared. So get 15a to the 4th power plus 6a squared. Okay, so this next one is bigger. It has more variables, but we're going to do it in the exact same way. So once again, we're going to separate this into three separate terms and then simplify each term. All right, so I've separated this into three separate terms. So now we can divide. We have 40 divided by 8, which is 5. And then x cubed divided by x squared, which will be a single x. Y squared divided by y will be a single y. Now we have plus for our second term. 24 divided by 8 is 3. X squared divided by x squared is 1. So there are no x squareds here. Y squared divided by y will be a single y. And then minus 16 divided by 8 is 2. And again, we have x squared over x squared, so there will be no x squareds. We have y cubed divided by y, that will be y squared. So 5xy plus 3y minus 2y squareds. Okay, so that's how it looks when we're dividing by a single term. In the next part, we're going to see how it looks when you divide by a binomial, which is two terms, right? And it turns out that the steps we follow are really similar to how you do division with numbers. And so I wanted to show you or remind you how that goes. So let's say we're going to divide 2,985 by 6. Our first step will be to divide. 6 divides into 2, no, divides into 29 though. 6 divides into 29 4 times. Then we'll multiply 4 times 6, getting 24. Then subtract 29 minus 24 is 5. Then bring down that 8. And then we're back to divide again. So we'll have 6 goes into 58. So 6 times 9 is 54. 9 times 6, now we're multiplying again. 9 times 6 is 54. Subtracting 8 minus 4 is 4. We'll bring down our 5. Divide once again. 6 divides into 45 7 times. Multiplying, 7 times 6 is 42. Then we'll subtract and we'll get 3. Here you would stop and say the remainder is 3, or you could continue with a decimal. For our purposes, it makes the analogy better if we just do it the way we did in grade school and stop and leave a remainder of 3. So we saw that this was kind of a 4-step repeated process: divide, multiply, subtract, bring down. And it turns out that we're going to do the division with polynomials in the same way. Here we have x plus 5. We're going to divide that into x squared plus 9x plus 20. Our first step will be to divide. And here we only look at the leading terms. X divided into x squared, that's the same as x squared divided by x. That will be x. X divides into x squared x times. Then we're going to multiply. When we multiply, we'll multiply that x by both the x and the 5 in x plus 5. So we have x times 5 is x times x is x squared, and then x times 5 is 5x. Okay, that's the multiply step. We did x times x plus 5, getting x squared plus 5x. Next, we'll subtract. Subtract x squared minus x squared is 0. 9x minus 5x is 4x. Then we'll bring down our 20 and back to divide again. X divides into 4x 4 times. X divides into 4x 4 times. Multiplying, 4 times x is 4x. 4 times 5 is 20. And then when we subtract, we get a remainder of 0. So it turns out that x squared plus 9x plus 20 divided by x plus 5 is equal to x plus 4. And you can check that by multiplying x plus 5 by x plus 4, and you'll get x squared plus 9x plus 20. Okay, this one divided in evenly, so it worked out nicely. Let's try the next one. We'll see if it divides evenly or not. This time we have y's. We have y plus 3. That's going to divide into y squared plus 10y plus 21. Okay, first step is to divide. Y divides into y squared, y times. Multiply. Y times y is y squared. Y times 3 is 3y. Okay, that was the multiply step. Next, we will subtract. Y squared minus y squared is 0. 10y minus 3y is 7y. Bring down the 21. Y divides into 7y 7 times. 7 times y is 7y. 7 times 3 is 21. So here we'll subtract and we'll get 0. And this means that our quotient, our final answer, is y plus 7. And again, you can check that y plus 3 times y plus 7 equals y squared plus 10y plus 21. Okay. Let's see if we can find one where it doesn't come out even. Here, our leading coefficient is a 2, so that changes things a little bit. We have x minus 4. We're going to divide that into 2x squared minus 3x minus 20. Okay. X divides into 2x squared, 2x times. Now multiplying, 2x times x is 2x squared. 2x times negative 4 is negative 8x. And then we'll subtract really carefully. 2x squared minus 2x squared is no x squareds. Here we have to be really careful. What's going on in the next column is we have negative 3x, and we're subtracting from it negative 8x. That's negative 3x plus 8x, actually, and that will be 5x. Be careful that you are interpreting this dash as a negative number, not as a subtraction. And make sure that you can read through that to the point where you get 3x, negative 3x, minus negative 8x being 5x. And make sure that you're not getting negative 11x because that's incorrect. Okay, let's bring down that negative 20. That bit about the subtraction is tricky and does take some getting used to, but you will be okay. Okay, x divides into 5x 5 times. 5 times x is 5x. 5 times negative 4 is negative 20. And once again, this one has a 0 remainder. So the quotient is 2x plus 5. 2x squared minus 3x minus 20 divided by x minus 4 is equal to 2x plus 5. And that means that x minus 4 times 2x plus 5 equals 2x squared minus 3x minus 20. But our answer to the question is 2x plus 5. Okay, let's try this next one. This next one has a degree 3 dividend, so a little bit bigger polynomial, but it's going to work the same way. We'll still divide, multiply, subtract, and bring down. X divides into x cubed, x squared times. Then multiplying, x squared times x is x cubed. X squared times 2 is 2x squared. Okay, now subtracting, x cubed minus x cubed is no x cubed, those are gone. 5x squared minus 2x squared is 3x squared. Then bring down our 8x. X divides into 3x squared, 3x times. Multiplying, 3x times x is 3x squared. 3x times 2 is 6x. Okay, now we are subtracting. 3x squared minus 3x squared is no x squareds. 8x minus 6x is 2x. Then we'll bring down our plus 6. X divides into 2x 2 times. Multiplying, 2 times x is 2x. 2 times 2 is 4. And this time when we subtract, we actually get a non-zero remainder. So this time our quotient is x squared plus 3x plus 2. And our remainder is 2. And we can write x cubed plus 5x squared plus 8x plus 6 divided by x plus 2 is equal to x squared plus 3x plus 2 plus 2 over x plus 2. So we have the quotient plus the remainder divided by the divisor. Okay, let's try one more. Here we're dividing x plus 2 into x cubed. Here, notice that it goes x cubed plus 3x. There's no x squared term. When that happens, you want to insert the missing term, make a plus, in this case, 0x squared. That's going to help us keep everything lined up correctly. When we do division with numbers, like 1034 divided by 27, we can use place value to keep track of the place value, right? Here, the 1 means 1,000, and how you know is the fact that, well, the 0 is in the hundreds place. If it was 134, it'd be 134, not 1,034. The zeros help us keep our place value. With polynomials, we don't have that kind of setup. So in order to help us keep everything lined up for our division problem, we're going to insert that missing term to help us keep everything lined up. Okay, x squared divides into x cubed, x divides into x cubed, x squared times. Now we're multiplying. X squared times x is x cubed, and x squared times 2 is 2x squared. Subtracting, the x cubes go away. 0x squared minus 2x squared is negative 2x squared. We'll bring down our plus 3x. X divides into negative 2x squared, negative 2x times. Multiplying, negative 2x times x is negative 2x squared. Negative 2x times 2 is negative 4x. Okay. The x squared terms go away. Here, once again, you have to be very careful that this dash is a negative 4. We're doing 3x minus negative 4x. So you should get 7x, not minus x for this. We're subtracting negative 4. 3 minus negative 4 will be 7. Okay. X divides into 7x 7 times. 7 times x is 7x. 7 times 2 is 14. We'll subtract, we'll get a 0 remainder. What was new about this problem was that missing term thing. Okay, but we were able to handle it just fine. Okay, we just have a couple more examples to do, maybe one. So let's take a look. For this one, we have 125x cubed minus 8. We're going to divide it by 5x minus 2. On this one, you'll notice that it goes straight from x cubed down to 8, and there's no x squared or x terms, which is why when I wrote the problem down, I put a 0x squared and a 0x. So let's go ahead and do the division then. 5 divides into 125x cubed. 125x cubed divided by 5x will be 25x squared. Okay, now we're multiplying. 25x squared times 5x will be 125x cubed. Now multiplying squared terms, 25x squared times negative 2 will be negative 50x squared. Now we can subtract. Okay, the x cubed terms go away. We're going to have 0 minus negative 50. That will leave us with positive 50x squared. 5x divides into 50x squared, 10x times. And now multiplying, 10x times 5x is 50x squared. I had forgotten to bring down my plus 0x. 10x times negative 2 is negative 20x. X squared terms go away. 0 minus negative 20 will be 20. So we have 20x. We're almost done. Minus 8, we'll bring down that minus 8. 5x divides into 20x 4 times. 4 times 5x is 20x. 4 times negative 2, negative 8. We'll subtract, we'll get a 0 remainder, and that will do it. So our quotient is 25x squared, 10x, and 4. Or we could say that 25x squared, 10x, and 4 times 5x minus 2 equals 125x cubed minus 8. A couple of other things to note when you're doing this is the degree of the dividend. Here, this was 125x cubed. That was degree 3. We're dividing something that's degree 3 by something that's degree 1. 3 minus 1 is 2. We're going to have a quotient that is degree 2. Also, we put the problem, the divisor and dividend in standard form, that is descending order by degree, x cubes, x squareds, x is the numbers. When you do that, the answer is going to be in standard form too. So you'll notice it came out x squareds, then x's, then numbers. So those are a couple of things you can watch out for as you do your work to make sure that they happen, and that can help you spot errors. That takes us to the end of our look at this section on dividing polynomials. Let me know if you have any questions, and have a great day.